Right, back again. So I've got the housing here, I've just drilled a few holes through it. Meter's gone in, and just make sure you get the washers right. You need a washer on first, then the wire terminal, then the washer and a lock washer, and that's all good to go. Crimped and soldered, and that's been zeroed. Probably not accurate, but it'll give us a close enough idea. I'll probably link up another meter to the machine at some point just to test it on an expensive meter, just see how far out this one is. So a bit of masking tape onto the top. I've drilled through some, I think they were 5.5mm holes, but it's pretty much whatever you've got really. So that is that. So yeah, wash the masking tape. Just allows easy marking of the hole position, and it also stops the drill from moving around. I did cut that out in the end. Can't remember whether I showed that on the other video or not. So yeah, that is going to go down through there. And feed it through, and that is literally going to sit just there. That all lines up quite nicely. It would have been nice to have it in the middle of the screen probably, but that would mean the cutout is then visible. So I've done these holes quite tight, so I'm going to need the Allen key just to actually the holes here also are quite tight, so I'm going to get the Allen key and just put the bolts through there, and we'll be back in a minute. If you are going to print one of these off, unless your machine's really finely tuned, and I thought mine was, it might just struggle with the area just here, so you might just want to add some supports there. I had a couple of stringy bits which I've just melted and scraped. Could have done better with that frankly, but yeah, just do some supports there if your machine's not absolutely perfect. So yeah, let's just get this in place and we'll be back in a minute. Okay, that is in place, and yeah, pretty good position really for monitoring exactly what's going on. So as usual, there's not enough wire here to do this outside the machine. I will, yeah, we're going to have to cut it in there I think, so I'm going to have to pull the machine out again to get to that, and yeah, obviously it's the thin one that goes to the cold end of the tube, not the hot end. You could do anything with that, it's not going to end well. So don't be touching any of this if you don't know what you're doing, and especially make sure it's switched off and unplugged before attempting any of these things. So bags of room under there, as you can see. Make sure you use locking washers or nylock nuts like I've used. You don't want these vibrating loose and falling off into here. Not likely to do any damage, but frankly it's not worth the risk. So yeah, nylocks on that, and yeah, we are ready for connections this afternoon. I'll just use probably little bullet push fit connections, and that way we can plug the meter in and make sure the wires are the right way around, do a quick test burn, see what the readings are, and then I'll connect up my one of my other meters from the workbench and just see what the readings are and how far out this might be. So, but yeah, and honestly, if you buy a CO2 machine like one of these and you don't have a milliamp meter, I would advise not even using it until you've got one fitted. This is a tenner. If you've got 3D printing capabilities, you know, this is pence to produce. A couple of bolts, a couple of bits of wire, and then find out what the manufacturer's ratings are for your laser tube. Really important not to overdrive these. I haven't, because the only thing I've been cutting is 3mm ply, and right up until I tried to do some perspex and realised that it wouldn't actually cut through anywhere near the correct settings that Red Dragon give on their power calculator. That could be the power calculator is absolutely miles out, but you'd have to hope that it wasn't. Otherwise, what's the point of writing the program? But yeah, anyway, look, there we go. Fit one of these as soon as you get your machine. Okay, so I've just I've done this cable correctly. That is all insulated with the heat shrink. We've got I think 3 different sections there, so that's done. Haven't done this section yet, but the meter's linked up, and we will get some readings as it is like that, and then I'll plug 1 or 2 of my other meters in and just compare readings. I was just having a little fiddle with this, looking at the minimum power setting that this laser will fire on, and at 3% we have nothing, but it will fire at 5, weirdly enough. I'm just going to check and do 4. Really didn't expect it to fire at this lower, got these bloody lights, this lower level. So let's have a quick look at that. We'll just hit the pulse button. Yeah, so nothing there. We get a little deflection, but the tube's not firing. But if we go to power and just bang in 5 for all of the figures and enter, it will fire now, I think. I'm just going to see if we can get the camera in the right place, and we'll just hit pulse, and there you go. That's pulsing no problem at 5% power. And if we look, or if we do a quick pulse, and if we press and hold, so yeah, interesting. Obviously we've got that connected the correct way. If you get the meter going the other way, just turn off, power down, and swap the connections over. So let's just pop the powers up for the pulse. Let's go to 10. Oh, I've got the fan on, I'm beginning to smell smoke. There we go, that's the extraction on. So max 1, 10, 5 minimum, max power 1 and 2 doesn't matter because there's not a second tube. Oh, goddamn right. So let's give this a pulse. Let's just, can we see it from here? We can't. And we'll have a little look here. Press and hold. 4.5 milliamps. That's at 10. So let's bump it up again. Let's go to. Actually, let's jump a bit of a higher amount this time. So I'm going to go up to 30 and pulse just under 6. You can see that one not through there. Okay, let's go to 50. And we'll pulse that. Well, I was expecting, you know, higher milliamps being drawn at these levels, so I don't know whether that is a indication of a problem. Let's go to 75%. I never expected to power it at that high. Here we go again, pulsing once and pulse and hold. 18 milliamps, you know, below the tube spec I would have thought, Let's just go and change power to 80. And we'll just pulse and hold. 19. So yeah, let's bring that back down to the 5. That's perfectly okay for. Actually, let's put it on 10. We're only using that for alignment purposes. And just pulse again. There we are, back down to, what is that, 4.5. Okay, so I'm going to unplug those and we'll get some heat shrink covering that and get that sealed after perhaps running another meter on it. So yeah, back in a minute, but you can see that is working successfully. Okay, so we are back again. I've just put the meter probes into the wiring, and we're just going to run through some settings, power settings, and I'm going to write them down at the same time, and then we'll just go back to the analog meter and we will compare notes. So we are going to do 5% power first of all, and write this down. So 5% pulsing now, 2.66 before that. And now we're going to go to 10%. Now 4.24, and the next one we're going to go to 20 now. 3 point, can't be right, I don't think that went well. It's gone straight through, so let me look at that. 20, why is that less? Interesting. Let's change to 30. I'll go back down to 20 on the power. .06, very strange. Just making me question the 10% value now. Maybe I didn't enter that correctly. Let's have a look. 10%. Enter. Right, pulsing now. 4.19, 4.24. Yeah, so we've gone up 10% and the milliamps have dropped down. How the hell does that work? Let me go to power 20, firing again. Very strange. Right, power 30, 5.73. And now we'll go to 40. Now 8.9. And now 50. Now 11.65. And up to 60. Now 14.4. 70%. Now 17.09. So we're looking around 3 milliamps approximately per 10%. Now let's go to 80, but I'm going to call it a day there. So 80% is pulsing now. 19.4542, we'll call that 19.42. Oh, sod it, let's go to 90 just for the hell of it. Still don't think we're higher than the milliamps that we can use on this is. So we'll do this quickly. Pulse at 90%, 20.63, okay. So that is where we will leave that. So I will get that all written down. We will get those wires sorted out properly, and we are done. Okay, so we have the results from the fairly accurate 01 meter, and now we're going to compare to the analogue meter, and we are starting at 5%. I'm going to have to do this left-handed, I think, because I need to write these figures down ideally. Where can we write that down? At the back perhaps. Okay, so we are selecting 5, and we'll see what that does. Quick pulse. Just done this, I would say that was 2.9. 2.9, we had 2.66 with the other one. And let's go and select the next power, which was 10, and we'll check that. That is 4.5, and we've got 4.2 on the other, on the digital. And let's go to power 20 and enter that. Oh, sorry about these lights. And we'll pulse at 20, and that's given us 123.1. And strangely, there's a drop again there. It was 3.8. It dropped from 4 to 3 with 20% power. I really don't understand how that can be. But that reading was pretty accurate actually on the analog and digital. So let's go to power 30, and we'll try again. So we're expecting 5.73 or thereabouts. Oh, hello, why is that not pulsing? Oh, because we're still on the pulse page. What an idiot. Right, here we go. 30%, 5.73 is what we're looking for. Yeah, that's pretty close. That's 5.9, I would say. 40%, we're looking for 8.9. Let's get 40% in, enter. What did I say? 8.9 we're expecting now. Oh yes, but absolutely bang on. 8.9. Really wasn't expecting accurate readings from this, especially for a tenner. Okay, so we're going to go to 50% now and enter. 50% we're expecting 11.65, so here we go. Bloody hell, it's pretty much spot on. 11.6. This is a surprise. 60% power. There we go, pulsing now at 60, we're expecting 14.4. No, that's not right. That's nothing like it. Okay. We're getting 11.5 at 60. Oh, hang on. No, it's not right, is it? 11.5 at 60% power. So now we're starting to find a big difference, which could well be a problem if you haven't taken these readings. So let's go to power 60 and enter. Now power 6, oh, hang on a minute, have I skipped one here? Bollocks. No, we haven't, that's okay. Oh, I have, what's going on? 50, no, sorry, 5, 10, 15, 20, 30, 40, 50, 60. Did I already do 60 or did I just do 50 again? Folks. Hang on, let's do 60. I think I may have done the wrong figure. So we're on 60% and we've got 14.2. Yeah, that's my mistake. I did the wrong value twice, or the same value twice. 14.2. So yeah, my mistake. So let's go to 70. Okay, 70. We're expecting 17.09. Let's have a look. And we've got 17 as near as damn it. So 17, 80% is 19.42. 80%. Okay, 80% pulse, 19.42. 19.1 possibly, so 19.1, and final figure is 90%, and that is going to be 21.6 is what we were expecting. 21.1 really. So pretty close. And what's the worst error we've got there? I think at the 90% we've got a 0.5, sorry, yeah, 0.5 milliamp error, 0.3, yeah, so the lower ones are all pretty accurate, but the highest one, 0.5 milliamp difference, so yeah, pretty good. I'm happy with that. I don't think we need to worry. We really need to know the tube specs now and how this compares with other people's 50 watt lasers. And ideally I need to get into the back now and just check the colour of the laser plasma as it's being generated. But might wait for a day or two before we drag this all out again and just speak to a Red Dragon and mention it on the forum as well, the results here. Anyway, hope that was helpful. If you do have a CO2 machine, I wouldn't even use it unless you've got a milliamp meter fitted and you have checked the manufacturer's specifications, so you know exactly what you are or should be dealing with. Wondering why that lid isn't shutting properly. Probably that rubber foot. Okay, so there we go. That was main project for the holiday few days off sorted.